All right, let's do some Mathity-Math. Now, first things first, I have my pencil, and I chose a pencil because I would like to erase it if I make a mistake, and here's my eraser. Remember, guys, it is okay to make mistakes. Our goal is just to make sure we learn from those mistakes. And with that said, let's go. Here we go. Number 1, okay, it says evaluate. So what is 569 to the 0 power? So this is just making sure that you understand that exponent rule, that anything to the 0 power is in fact 1. And that's that. Here we go. Number 2. Oh, where did it? Oh, there it is. Number 2. So this question, I think I made a little bit trickier than it should be for this grade band of 1, 2. But anywho, the lesson is good to learn regardless. So it says rewrite your answer so the exponent is a positive value. So this one right here you can see is a negative value. And then it says do not evaluate the expression. In other words, we do not need you to take 9 and then multiply by itself 22 times. That'd be a big number. That's not what we're doing here. But anywho, the reason why I made this one a little bit trickier than it needed to be for this band, this grade band, is the base of this one is 1/9. Because I put it in parentheses, it's all together. So if we use that exponent to reciprocate or to flip the base, what we actually end up with is 1/1/9 to the, my holder fell. Sorry about that, my holder fell. We are back. Okay, so anywho, so that base now is a fraction, which is not something we typically do, but there is something really interesting here that we can do. And the interesting thing here is that we can do is then, well, we could actually look at this whole thing and say, well, is this not the same as saying 1 divided by 1/9 to the 22nd, right? Because that's 1 divided by. So we could actually take a second to think about this and say, well, you know, I know that this power rule means I multiply by the exponent inside, and these are actually just like hidden ones. So hypothetically, if you wanted to take this a little further, we could say that this is the same as saying 1 being divided by 1 to the 22nd power and 9 to the 22nd power. And then we can say, well, I know that dividing is the same as multiplying by the reciprocal, which would be then, this is like saying 1 times, now watch this, 1 to the 22nd power is 1. So if I reciprocated this, I would get 9 to the 22nd power over 1, which is really interesting because 1 over here could actually be rewritten as a fraction, 1/1. And if you multiply that out, you would actually end up with this result of 9 to the 22nd power. Like I say, I did not mean for that question to kind of go that direction. I should not have made the base a fraction. Not really what I was trying to look at. Anywho, good lessons learned. Keeping it moving. Next part, number 3, says rewrite your answer so the exponent is a positive value. So this -3, we want to rewrite it. We're not really evaluating. It says do not evaluate. So we're going to rewrite it. And again, all this is saying is if my base is 8, right, and I have this negative, everything can come down and it would be rewritten as this. And there you go. And that's just understanding the power of a negative exponent. And there we go. Moving on. We're gonna do something, let's do a fancy transition. To the next page. Wow, that was crazy. Okay, so here we go. Looking at the next one, it says, write your answer as a value with a positive exponent. So they're saying, you know, just leave the exponent and then evaluate the expression or go find the answer. And we can write our answer as a whole number or a simplified fraction. So this one just wants us to understand the division rule. We have exponents and understand that this, because they have the same base of 9, is the same as that, which is the same as that. And that's the first part. And the second part, 9 squared is 81. And there we go. Okie dokie. The next question, question 5. Same instructions, so I'm not going to read those to you again. But this is just, do we understand the product rule, or where we multiply, the multiplication. So because these are the same, essentially we're just going to add those exponents. That's a rule we know and have practiced. So this is the same as that, which is the same as that. And 2 to the 7th power, if you did the math in your head. Now we can just do this real quick the old-fashioned way. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. And that is that. Next up, it says write the expression as a fraction with a positive exponent. And you know what? This one actually should probably go back to the 1-2 band, and I'll bring the other one forward. But same idea, the power of negative exponents. We reciprocate this whole thing, and that is going to end up looking like that. Okay? And the thought process here, if we want to kind of make sure we really understand the why of all this, y to the negative 6th is the same as y to the negative 6th power over 1. Okay, and so if we reciprocated this, the 1 goes to the numerator and the base and exponent go to the denominator, right? That's how that happened. Okay, so that's just the idea behind it. All right, moving on. Got to evaluate here. Now this one you have to be careful, because just like I did on the 1-2 question earlier, the base of this exponent now has parentheses in it. So that whole shebang has to be evaluated. So this is the same as saying negative 2 times negative 2 times negative 2. Remember, negative, positive, negative. It follows that pattern. Math is built on patterns. So 2 times 2 is 4, times 2 is 8. And remember, it was negative, positive, negative. So we actually get a negative 8 for your solution. All right. Next one. Now, in this case, our base is 4. And the negative is actually not being evaluated. It's not getting squared. Only the 4 is. And one way we could look at this is like this negative is actually the same as like a negative 1 that then is multiplying 4, and the 4 is being squared. And taking that further, that's like saying negative 1 times 4 times 4. Well, 4 times 4 is 16. 16 times negative 1 is negative 16. And with that, we will go to the next page. It's a crazy transition. Whoa! Ooh, here we go. Okay, and now we're on to the next band. So this one's just kind of starting to combine our ideas a little bit. And so when we look at this, we have our constant values and we have our variables of b. And remember, because we can expand these to make them a little more clear, this is the same as saying 6 over 3 times b over b cubed. And this makes it a little more straightforward, because I know that 6 over 3 is 2. Let me just get this going. 2, okay. And if I look over here, my b's, so this is like a b to the first. So this is a division rule. So 1 minus 3 is negative 2. So now this is 1 times b to the negative 2 power. And again, if we think of these as fractions over 1, it makes things very, very clear, because then this will reciprocate. So I get 2 over 1 times 1 over b squared. And if we stick it all together, it'd just be 2 over b squared. There you go. Coming on down, question 10. Same song and dance. Now, because I just did that whole process up there, I will do this one a little more straightforward. You know, I know 10 divided by 2 is 5. And I have a Q1 up here. So be careful here. This is like saying Q to the first, and it's dividing, so I subtract. And what do I subtract? Negative 1. And this is actually like saying 5q1 plus 1, because this is saying subtracting the opposite of 1, okay? So that's just like adding. And what we get here is 5q squared. Woohoo! Moving on. Right, so we have 4c to the 5th times 10c. And again, all the instructions are pretty much the same here, so no big deal. And again, this one's a really fun one to think about and really appreciate the communicative nature of multiplication. So for instance, this is the same as saying 4 times c to the 5th times 10 times c. And I'll put a 1 there just so we're all clear about what's going on. Now, if you think about the communicative nature of multiplication, this means these can all go in any order we want. So I could also just say this is like saying 4 times 10 times c to the 5th times c. Well, 4 times 10 is 40. And in this case, we just add these up. So you'd get c to the 6. 40c to the 6. And there you go. This one is actually the exact same process as this one. You can just expand it out and get everything where you need to be. But long story short, 10 times 6 is 60, and b times b would give you b squared. Let's do something nice. Let's not do any more explosions. Let's see here. I'll figure something out nice. Okay. All right. Oh, time for, oh yeah, here we go. Big transition. Woo, we're doing so much stuff. Okay, we're back. Okay, here we go. Woo, buddy. So things are getting, turn up the heat a little bit on this one. A really great opportunity to expand it out and rewrite it in any order that helps it make sense to you. Because again, it's all multiplication, all multiplication. So actually, I'll go ahead and just kind of do it as we go. So I have an 8, and I have a 2. Those are my constants. I have a u to the 6th, and I have a u to the 2nd. I have a v with a hidden 1. I have a v with a 3, and I have a w with an 8 and just a w with a hidden 1. And now I can just put it all together. 8 times 2 is 16. I know these are the same base and I'm multiplying, so I can just add them up. So I have u to the 8th. This, again, same base, so I'm multiplying, so I can add them up. V to the 4th. Same base, multiplying, so I get to add them up. W to the 9th. And that is that. Boom. Okay, this one goes into the power of a power rule. And so if you think about this one, this is really just an extension of when we were multiplying and doing the products, right? It's because if you think about it, b to the 4th squared is the same as saying b to the 4th times b to the 4th, which is the same as saying, well, I got the same base, so I can just say b to the 4 plus 4, which would give me b to the 8th. And that would be our answer. Or you could just make sure you know the power of a power rule. When this happens, you just multiply. 4 times 2 is 8. Ta-da! Oh, okay. Almost done, almost done. This is the same idea here, so we're just going to multiply and understand the power of the power. Well, negative 6 times a negative 1 is the same as saying n to the 6th, because we just multiplied negative 6 and we multiplied negative 1. And again, now we're just really kind of being a bit redundant here. It's the same idea. 9 times negative 5, so you get k to the negative 45. And if you wanted, because you don't want to leave that negative exponent, you could show off a little bit and write it like that. Both those are awesome answers. A-OK. And that is it. As always, be kind to yourself. Be kind to others. Be safe and make good choices. Bye.